All right, then I'm happy to present our work on conversational exploratory search using knowledge graphs. And I'd like to start with generating first some initial idea about what this paradigm of conversational search is. So it basically frames information retrieval processes between a user and a conversational interface into multi-turn dialogues. And this interface is then connected to a large knowledge base, which can also be in the form of a knowledge graph. And these kinds of conversational search systems are particularly useful for exploratory settings, where the user is maybe unsure about the information goal. Also, the conversational agent can help clarifying some concepts in the information domain. And of course, the user doesn't really need any technical background knowledge. He can just ask questions in natural language. And these kinds of systems have been built with knowledge graphs, but mostly really for simple question answering conversations that maybe only go one turn, or other RAG type systems. However, this interactive process of exploratory search really hasn't been researched yet thoroughly. And because of this, we wanted to find out how we can leverage the semantic structure in knowledge graphs for exploratory search. As a use case, we chose here the discovery of relevant publications in the field of natural language processing. So given a problem of interest, like summarizing financial documents, how can we extract useful insights and find relevant papers on this topic? How did we approach this? First of all, we needed to generate the knowledge graph. And here we sourced papers from the ACL anthology, so over 85,000 papers. And there is a lot of metadata that comes with these papers, which we automatically converted then into nodes and relationships in our knowledge graph, like the venue or the author. Furthermore, we used an existing NLP taxonomy from a related work, which is here referenced below, and used also here a classification model to assign each publication a research topic in the area of NLP. And even more, we then clustered thematically similar papers into groups. For example, inside one research topic, we would then still cluster papers that focus on documents in the medical domain or in the finance domain, or papers that you would use a similar type of model, etc. Having now constructed this knowledge graph, we built the conversational interface on top of it, which basically powered a three-phase search process I want to explain to you. So you see at the bottom is here the conversational flow diagram. And what basically happens in the first step, taking all papers, the user first describes a problem or a topic of interest, like I want to analyze emotions on tweets. Then the system would suggest the topic from the NLP taxonomy, also along with some definitions and listing also related NLP topics. Then the user chooses one of these topics and then can iteratively select some clusters. And by selecting cluster by cluster, of course, the number of relevant paper further narrows down until at the lowest cluster level, the user is presented with some publications and then can use generated comparisons about the similarities and differences of these papers. This was implemented in the following architecture. Of course, I don't have time to go through all of these components. The four core subsystems here is the dialogue system at the center, which interacts with the user through a text-based chat interface here as a web application, is connected, of course, to the knowledge graph. And we also connected it to another VM where we hosted a generative language model. And all these white boxes with the components basically support this three-phase search process, which I just explained, consisting of topic classification of NLP research topic, then further clustering papers and also finding good names for these clusters. And at the last stage, then comparing the different papers with generating some summaries. Let's look at the evaluation of these like three steps in the search process, starting with topic classification. So here the problem was that the user, for example, had a question phrased in layman's terms, like how are computers able to respond when we ask them questions. And then the system should suggest, do you maybe mean the topic of natural language interfaces? So what we did is we synthetically generated a data set for all the topics in the NLP taxonomy, and then generated 1,600 of these layman's terms questions, and then had a data set, I think, of training examples around 1,600 and 160 test examples. And for this topic classification, we tried out the vector search. We also tried out prompting a large language model, but in the end, the best topic classification model was a fine-tuned set-fit model, where we used the sentence transformer model. More details about this are available, of course, in the paper. So for the thematic clustering at the second step, we then tried out different distance thresholds to ensure that within one cluster, we didn't have too many papers, but also not too few papers, and to then find descriptive labels for each cluster. We first applied a TF-IDF vectorizer to extract important words. And after that, we prompted the large language model to generate a bit more understandable and descriptive cluster names. One example was then emotion detection in social media text. Then there's a third step for generating the comparisons between two papers. We again use the same large language model to generate these comparisons in real time. And here we didn't feed in the full abstracts in the large language model, but previously extracted only the objectives and the results. And we didn't do this with the large language model, but actually with the fine-tuned Cybert model. We fine-tuned it on an existing data set, which is also referenced here, achieved a quite good score of F1 75%. And this helped us then to really only generate the comparisons for the objectives and the results of the papers, which were then directly inserted into the prompt. And then the comparison were generated in real time. Of course, it's not only interesting to look at the performance metrics, but also about how the end-to-end system works. And this is why we designed for the dialogue system a user study, where 40 participants interacted with our system and afterwards filled out evaluation questionnaire. So study design was as follows. The participants were randomly assigned to group A and B, and this determined with what search scenario 1 and 2, they interacted, with what interface they interacted. We had a total of 2 interfaces. First, the conversational interface that we implemented, and then we compared this against the graphical interface. And the 2 scenarios that were explored were first about analyzing the emotional expressions of tweets during the COVID-19 pandemic. And the second scenario was about how we could generate multiple choice exam questions for material in the field of computer science. So here are the 2 interfaces depicted next to each other. On the left-hand side, the conversational interface, pretty straightforward, just a text input field and a scroll bar for the dialogue history. On the right-hand side, this was the graphical interface we compared, which was just the ACL anthology search, which is powered by Google Search with some filter options as well. So in terms of the results, so here are some metrics of the evaluation questionnaires. And the first finding we see here is that on average, there is a tendency for the conversational interface to perform better than the graphical interface. If we look at the system's ease of use, we see that in the first scenario, it's quite comparable. In the second scenario, the conversational interface outperforms the graphical interface. And this pattern continues then for the readability, the correctness, but also of the usefulness of the presented information. And in the end, also manifests in the overall satisfaction that for both scenarios, the conversational interface seems to be a bit better in terms of the ratings. And there's another finding we had is that if we look at the scores of scenario 2 for both interfaces, they're actually a bit worse. We can also visualize this, the same data here in box plots, where we see that whenever we go from scenario 1 to scenario 2, we see that for both interfaces, the rating distribution shift towards the lower end, which indicates that maybe scenario 2 was a bit more difficult. So this exploration of finding relevant papers seemed a bit more challenging for the users. And what we see here is that while both systems achieve lower scores, this effect is much stronger for the graphical interface, while the conversational interface still maintains quite consistent performance. So it performs still quite well, even when a scenario is more difficult. To conclude the findings, first of all, of course, all our training data, the fine-tuned models, the implemented systems, but also the evaluation questionnaires are made available in our GitHub repository. We saw from our evaluation that it's quite promising to combine conversational interfaces and knowledge graphs for exploratory search, and that users liked this kind of interface for exploration in comparison to the graphical interface. Especially here, things like readability, usefulness, overall satisfaction were higher rated. And this was also confirmed by the feedback comments the participants wrote. And they especially emphasized that, for example, it was easy to use and they didn't really needed to know the search terms to start the exploration. To conclude, for future efforts, we want to focus on further improving the dialogue system based on the user feedback. Many users wanted a bit more flexible dialogues, especially when reversing some choices. So maybe jumping back 2 clusters while you select clusters of papers. But we also see that there can be other domains for building these conversational exploratory search systems. We have a related work on exploring news articles, but in my opinion, all kinds of domains could benefit from building like this conversational systems for exploring information. By this, I want to conclude and looking forward to your questions.